Okay, you guys, yesterday we talked about finding the centroid of a triangle, and that video is posted on Google Classroom for those of you who are absent, because I know there was a lot of you gone for other school stuff. So today we're going to talk about altitudes, and we're going to find the orthocenter today, which is a different type of center of a triangle, and it has to do with drawing the altitudes. So an altitude of a triangle is a segment from a vertex to the line containing the opposite side, but it also has to be perpendicular, that's important, to the line containing that side. All it really says is, like this example here, the altitude's inside this triangle, and it forms a 90-degree corner from B to AC, basically, and that's point D there. It can also be outside of the triangle. If I were to take and try to draw a line from B at a 90-degree angle to AC, it's impossible because it just doesn't work. So sometimes you have to extend this line out to actually get the altitude or the height of the triangle, as in this case. Okay, so go ahead and take a moment, pause, draw a triangle ABC. It doesn't have to be perfect or anything, and I'm going to show you the steps in drawing an altitude. Okay, so now that you have this drawn, first things first, we're going to take my compass. I'm going to put, and it doesn't matter what point you start with, I'm just going to start with my compass point on A, and I'm going to extend my compass past the line BC, which is opposite it, and I'm going to draw an arc that goes below the line. It has to go below this line AC. Then I'm going to take my compass and move it, pinch it down a little bit. I'm going to put one of my points on this arc that I just drew on line BC, and I'm going to draw an arc like this. Okay, and then I'm going to flip my compass, put the other point on the other arc that I drew, like that. And then I'm going to draw an arc that crosses that. Then what I have is an arc out here, so then I take a line with my straight edge, we'll make it dashed so it looks like an altitude. And I'm going to take from this vertex A and I'm going to draw it through that point that I made out here. And that's an altitude, okay? So, and then you can actually erase this down to here because it only needs to go to here. And I encourage you to do this because you're going to draw several arcs, is delete your arcs with your eraser so it looks better, okay? So right now what I want you to do is, with your triangle that you drew in your notes, draw an altitude from B to AC and draw an altitude from C to AB. Pause the video, do that, and then I'm going to do the same thing, come back and see what it looks like. All right, if you've done it correctly, you should have something that looks like this. I've got 3 altitudes, okay? And this point right here, right there in the middle, because these are altitudes, and what I would do when you draw these is indicate their altitudes by a 90 degrees. That's a 90-degree angle. That is a 90-degree angle. And that is the orthocenter of your triangle. So we'll just, well, let's do it like this. We will label this right there. Make sure you label it in your notes. This is the orthocenter, okay? So that's the orthocenter of a triangle, and that's, or yeah, how you find it. Drawing altitudes from all 3 vertices, and that balance, it's not a balancing point, it's just another type of center in a triangle. So now what we're going to do is move on and show you how to algebraically find it when it's on a coordinate plane. So I've already drawn mine, but take a moment. So the vertices of triangle FGH are, F is at -2, 4, which is right there, that point, and I'll label that. Actually, let's just label it right now. Let's see, we'll make it blue. We'll keep it blue. So F is -2, 4. F is -2, 4. Okay, that's that point right there. G is 4, 4, which is this point right here. G is 4, 4, right there. And then H is 1, -2, which is down here. Oops, 1, -2. Okay. So there's my points. And we need to find the coordinates for the orthocenter. So somewhere in here I need a coordinate, an x and a y value that's somewhere in the orthocenter, and we're going to do it without drawing a or without using a compass, and doing it algebraically. So basically here, what we need to do is we need to find the equation of, let me draw an imaginary line and help you. We'll draw it in green again. Let's pretend here for a moment that I'm just sketching it. That looks about like 90. I don't know that for sure. So let's say we have that line, and then we're going to have a perpendicular or something that looks like that. And if I just find these two lines right here, the equation of this line right here and the equation of this line right here, I don't need to find this one because that's where they're going to meet. So we're going to find this coordinate wherever it is. And you can't just sketch it and guess. There's an actual way to do it. So right now, go ahead and draw this triangle. I'm going to delete these lines, and I'm going to show you. We're going to use some slope formula and some different things to figure out the equation of these lines. So I'm going to delete that one, and then I'll come back and we'll talk about how to find the equation of the line. Okay, so in order to find the equation of the line that goes from here to here at a 90-degree angle, first we have to know this slope of this line GH. Because if we know the slope of GH, in order to get to a 90-degree going this way, it's just the reciprocal. We've done that before when we talked about slope. And the same thing here. In order to go from G to FH at a 90, we need to know the slope of this line. Okay, so let's talk about how to find slope. First, let's find the slope of GH, this line right here. We're going to find the slope of that. So slope, remember, is y2 minus y1 over x2 minus x1. Okay, so I can just label these right now. If I'm looking at y2, y1, this is going to be my x1, y1. Up here, this is going to be my x2, y2. So I'm just going to plug them in. So y2 is going to be 4. Let me do it up here so I have more room. Y2 is going to be 4 minus y1, which is down here at -2, over x2, which is 4, minus x1, which is 1. Okay, so I'm just finding the slope of that line with the red arrow right there, this line right here, okay? If I do the math, that's going to be a double negative. That's going to give me 6 over 3, which is 2. So the slope of this line is 2. I don't want necessarily the slope of that line. I just need to know the reciprocal. Well, what's the reciprocal of a positive 2 over 1? So the slope, the reciprocal is going to be a negative 1 over 2. And that's going to be the slope of the line that goes like that. Okay? So in order to do that now, I know the slope. So let's do this is going to be the slope of the line. Whoops. This is going to be the slope. The slope of that is 2. Slope. So the slope of the line I need is going to be -1/2, the reciprocal. Okay? Let's do that over here. So let's use the point slope formula, which is y minus y1 equals m, or the slope, times x minus x1. That should be a review. We've done that. If not, you might need to go back and review what point slope is. And we know that this m value right here is going to be a -1/2, which we determined right there. So let's plug some numbers in. Let's go y minus my y1 value of f, because I'm going up here now, right? I'm going to use that point right there. So my y1 value is 4, equals my slope, which we determined was a -1/2, times x minus my x1 value is a -2. Like that. All right? Now we can revise. I'm not going to worry about the left side too much right now. I'm going to distribute this 1/2 like here and here. That's going to leave me with a -1/2 x. And -1/2, this is a positive 2 now because we're adding a double negative. Or subtracting a double negative, I guess. So a -1/2 times a positive 2 is going to be a -1. Okay? Now I can revise a little bit more. I can go add 4 here, and I can add 4 here. That's going to leave me with an equation of y equals negative 1/2 x plus 3. That's going to be the equation of the line that's perpendicular to that line right there. So I'm going to go ahead and put that in green because we're going to do a systems of equations to figure this out. That's that line right there. And I could graph it, I guess. Yeah, I could graph it. Let's do that. Well, we'll graph it later, okay? So then I have to do the same thing. I went like this, right? I drew this line, or I found the equation of that line. Now I have to find the equation of this line the same way, okay? So I'm going to do that. So go ahead right now and see if you can do it on your own, and then I'll do it with you, okay? We'll do that down right below here somewhere, and we'll find the equation of the other line. Okay, so first let's find the slope of this line now, and then get the reciprocal of that. And we've got the slope is going to be y2 minus y1 over x2 minus x1 for that line. So my y2 is negative 2 minus y1, which is 4. And all these points are, you guys, I'm taking points F and H. So I've got negative 2 minus 4, and then my x2 is 1 minus negative 2. So the slope, again, we're finding the slope of that line right there, is going to be a negative 6 over 3, which is going to be negative 2. So what's the reciprocal of negative 2? That's going to be a positive 1/2. So the slope of the line that goes through here is going to be a positive 1/2. So now I can do the slope-intercept. Erase that, clean it up. I can do the slope-intercept for the other line and figure that out. So I know my slope's going to be positive 1/2. So it's going to be y minus y1 equals m times x minus x1 again. All right. And I know my m is a positive 1/2. Okay. So I'm going to go y minus my y1 value, which now I'm using g right here. I'm using that point right there. So y minus 4 equals the reciprocal of negative 2 is a positive 1/2 times x minus 4, which is that point G up there. Okay, so we're just finding the opposite line. So let's revise that. We're going to get y. Okay, so we're going to get y minus 4 equals 1/2 x minus 2, if I distribute that across. I have to extend my page. Okay. And revise it some more. I'm going to add 4 to this side, add 4 to this side. That's going to leave me with y equals 1/2 x plus 2. So that's the equation of the other line. That's going to be the one that goes like this on my triangle, right? So that being said, now we could graph those and try to figure out the point, but there's actually a more precise way. If I take those two equations circled in green and treat them like a systems of equations, I can find my two coordinates that go in there. So what I'm going to do, I'm going to take, we'll switch to green now, and we're going to go y. I'm going to write my two equations vertically. There's one. Okay. Make sure it all looks right. Something doesn't look right there. Hang on just a second. Okay, so what I did is I took both equations of the lines and I wrote them vertically like this, and we're going to treat them like a systems of equations. Now, what we're going to do is we're just going to basically add those two equations and find my point. So, if I go y plus y, I get 2y equals a negative 1/2 x plus 1/2 x. Those are just going to cancel, and then 3 plus 2 is 5. So I've basically just eliminated the x's, and that's what you do when you use systems of equations. So then I solve for y. If I divide that by 2, I get my y value is going to be 5/2, which is 2.5. Okay, that's one of the points of my orthocenter right there. Okay, now let's solve for x. We take, excuse me, let's take this y value of 5/2 and plug it into one of my original equations, either that one or that one. It doesn't matter which. I am going to choose this one right here because it's positive, and positive numbers are a little bit easier to deal with. So I'm going to take this 5/2 and plug it in, this 5/2, and I'm going to plug it in right there. Okay, that's where I'm plugging it in. 5/2 equals 1/2 x plus 2. Now I can solve for x and figure out what my x value is. Okay, so my y value is 5/2. I know that. Now I can figure out my x value. So if I do that, let's take 2 away. Take 2 away. Well, the 5/2 is 2.5, and if I take, well, we can just do it longhand. So it's 5/2 minus 2/1. Gotta get a common denominator back in the 6th grade math thing. So this is going to leave me with 5/2 minus 4/2, right, which is 2. 5 take away 4 is 1. Denominator doesn't change. So 1/2 is going to be left on equals 1/2 x. That's what I get. Now if I divide, actually I'm just going to multiply the reciprocal. That's 2/1. That's going to cancel. That's going to cancel, and I'm just left with x on that side. Whatever I do to that side, though, I have to do to that side, right? So 2 times 2 is 2, or excuse me, 2 times 1 is 2, and I'm just going to be left with, those cancel, so I'm left with 1. So my x value is 1. So the coordinates, I know that's a lot of work, but the coordinates for the orthocenter is going to be x is 1, and which is this number. If I do that, there's my x coordinate for the orthocenter. Here is my y coordinate for the orthocenter, which is 5/2, or you can think of it as 1, 2 and 1/2. That right there is the orthocenter. So 1, 2.5. If I come up back, clear back up here and graph it. So if I go 1, 1, 2.5 is right there. That's my orthocenter. And if I wanted to, which, yeah, let's graph it, right? Let's graph it and see what we got. So the first line, we'll make it green, I guess. We'll make it bright green. It's going to be, ooh, that's not right. We need a line. We'll make it dashed and green. So my line's going to be right there. And this line's going to be right there through that point. And you can indicate that it is a true altitude by a 90-degree angle. That right there is my point at 1, 5/2. That's the orthocenter, 1, 5/2. Okay, that's lengthy, and I know it's a lot of algebra. But again, all you're doing is finding the equation of the 2 green lines, using them as a system of equations, and finding the x and y value, and you have your orthocenter.